Welcome back. In this video I'll be showcasing a memory storage system that is loosely based on both my block-based memory storage system and NopeName's single block-based memory storage system. By loosely based on both, I mean I use the same fundamental systems as both of them, but they are quite modified. Now, NopeName's single block storage allows him to store values within nested arrays, and those values are always integers. And my system allows me to store any data I want within a 16 by 16 by 16 block area, and it will seek the nearest possible memory address to write to and then write the information there, and it'll give you an output of what that memory address was. Then you can request the information from that memory address with only one command. But this sadly does not allow you to read or write to the first available memory value, because all values have to be filled for it to work properly. So it is a little bit less efficient, but it does allow me to input a value and then write or read from that value. NopeName's system can only read based on a certain value, but cannot write to it, because it has to be hard-coded on what integer he is inputting, while this uses some clever trickery with basically scrolling through data to write to specific slots. So let's go ahead and showcase how this is done. Or not showcase how it's done, let's showcase it first. So what you have here is, you see my hexadecimal converter here. And what we have in slot 0, we have information that is 0. Let's go ahead and see what we have in, let's say, slot, 1643. In 1643, we have an integer of 10. Let's go ahead and change that. Let's trigger, and let's write an integer there. Let's go ahead and write integer, 6543. And let's go ahead and read that slot again. And as you can see, we have the value 6543 in slot 1643. This does, as I said, allow me to read and write to any integer value, or any integer value into a thing, into a specific slot. So let's talk about how this is done first with a physical demonstration, then I will showcase the remaining or the actual system in the code. So what I'm doing essentially is, let's say we want the information that is in the magenta block. I can either read the information that is in that specifically by specifying that I want the information that is in slot 2, so 0, 1, or 2, or I can essentially scroll through the information. So what I'm doing is I am copying the white block here, let's say, and I'm placing it at the end, or at the beginning in this case, and then I am deleting that. And I repeat this again until the block or information that I want is at the forefront, and then I can read what is in slot 0. And then what I do is, for the amount of times remaining to get it back to white here, I essentially have to scroll through 3 more times. So let's go ahead and do that. I will copy what's in magenta, then delete magenta. I will copy what's in light blue and delete light blue. And then I will copy what's in yellow and delete yellow. And here we have again, the white is in slot 0, meaning it is back to how it was before. So that is essentially what I'm doing to get a specific memory position. Now let's go ahead and showcase how all this works within the code. What I have here is the formatting. I have a nested array system here, as you can see. Here's the primary array, which goes all the way down to the bottom. This is the secondary array, which goes all the way to here. And then we have the last array, which has individual integer values. This essentially allows me to have my x here in this array. Then I have my y here within all of these arrays, because this right here is the x value, then this is the y value, then this is the z value. So we have x, y, and z. Hopefully that makes sense. Next we have the read and write functions, which are essentially the same thing, except I am flipping whether I am writing or reading from a scoreboard. And that's the only difference in the write or read functions. And then we have our set here, which will run 3 functions that loop themselves until they're done doing their thing. What x does is it will scroll through the first set of arrays until it hits the value that is the same with what is in the hexadecimal converter's output. So essentially it will keep running until it gets the proper array into the forefront. Then once it's done, it will then run Y, and then once that's done, it'll run Z. The only difference here is for Y, I am reading off the second set of subarrays. Then for Z, I am reading off of the third set of subarrays. Then once that's done and written or read, I will then run a reset, which will then do what set does in reverse. As you can see, I am running X, Y, Z. Now reset runs Z, Y, and X. Now Z is effectively the same, but it keeps running until it has scrolled through in total 16 times. And the same thing with Y and X. The reason I'm doing it in reverse is because otherwise I would be setting information improperly and scrolling through the wrong set of arrays. So that is how it works. It is fairly simple once you get down to the core of it, but I mean, isn't everything? But yeah, that's everything. I will link Nopename's video down in the description below, as well as my block-based storage video as well. So that's everything I have here. Go ahead and check those out. But until then, I will catch y'all next time.